Welcome everybody to this webinar where we're going to be talking about an initiative called Enterprise Knowledge Graph. Let's talk principle that work. And today we are with some great speakers. We have Arindam Chundri from Capgemini, Dan Williams from Cambridge Intelligence, and Renaud Rox from Nexa Technologies. This webinar is very much about giving some ideas, some initial ideas that we were able to mature over many, many years of working in knowledge graphs. I think everybody here among the panelists, and how these are getting put in practice in enterprises, and what are some good ideas for making this come to life and what hasn't worked in the past. So it's an initiative that's very much generic, is not specific to any product, and we hope that you'll be able to then relate it to what you're doing today. So a little bit about the webinar agenda. So here I am giving a welcome and an introduction. And then we are going to be introducing obviously our panelists, which have a great background from different industries. And that's what's really fascinating about knowledge graph is, you know, how they apply cross industry and across many use cases within industry. And then I'm going to be giving you a very, very short presentation of what's kind of like this idea is behind this initiative and what was inspiring, you know, coming from a history of theoretical knowledge graph, at least in my case. And then we are going to give the floor to our panelists, presenting each one in their own experience, and then we're going to be opening the floor for questions. So yeah, sure. Before I start to my presentation, I'd like our guests to present themselves, and I will give a quick presentation just at the beginning of my slides. So Arindam, if you want to introduce yourself.
Thank you very much, Gio. Good afternoon, good morning, everyone. Looking forward to this opportunity to speaking to you today about our experience in knowledge graphs and, you know, graph databases in general. By way of background, you know, I lead the big data practice for Capgemini, which is a global consulting firm. You know, we're pretty large. We are about 200,000 people globally. I lead the big data practice and I focus on financial services. I've been in the industry for, you know, over 20 years now, and have, you know, seen the evolution of data in financial services, right from, you know, the mainframe days into, you know, RDBMS and Hadoop and big data and into you know, graph databases. You can almost say that, you know, it is making a comeback. You know, if you think about the mainframe databases that existed like 20 years ago. So really excited. You know, a lot of opportunities around utilizing, you know, knowledge graphs as well as graph databases in general. Right, a lot of opportunities to interconnect, you know, different sources of data and get intelligence from that. So hopefully you'll find the presentation useful, as I'm sure I will. Thanks, Gio. Back to you.
Well, thank you very much, Renaud.
Hello, good morning, good afternoon, everybody. So my name is Renaud Rox. Thank you, Gio, for hosting this webinar and inviting me in here. I'm currently the managing director of Nexa Technology. Quick word about the company. Nexa Technology is a French company dedicated for intelligence market, intelligence field. We are building big data and intelligence system for Ministry of Defense, Ministry of Government. So we have a very, very specific field of expertise. And of course, we need, and our customer needs, a lot of knowledge graph, and specifically knowledge graph that works. A bit of my background, I have engineering background in mathematics and computer science. I started my career in cryptography and security. And little by little, I moved from the cryptography to the interception and intelligence world, where I'm now for almost 12 years already.
Thanks a lot, Renaud. Dan from Cambridge Intelligence.
Yeah, hello everyone. My name's Dan Williams. I look after product management here at Cambridge Intelligence. For those of you who don't know us, we are a company providing visualization toolkits. So we're all about visualizing information. You'll see a bit more of that when I give my presentation. And we're going to be, I'm really particularly interested in how we can bridge the gap between technology and people, and in particular giving a great intuitive user experience for people when they're using technology. So my background is all software, really. I've been involved in software from the aerospace industry to geometric design and data management, and I'm now focused in visualization.
Thanks a lot, Dan. So I guess that's my turn now. I haven't really properly introduced myself as a founder, together with Renaud Delbrou of Siren, the company. We used to be called Siren Solution, now Siren.io. Siren stands for Semantic Information Retrieval Engine. And the original Siren engine was what me and Renaud and the team that we were, I was leading in a university 10 years ago, was developing to index the web of data, that it was the semantic web. Now that was the past. Today, in the company, in the Siren.io, we work on knowledge graph, having created a solution which is particularly lightweight. And but that's not what we're going to be talking about today. So today it's more a little bit of theory. And in fact, the first thing I'd like to go ahead and discuss is a little bit what is a knowledge graph in theory, and what led us to think, what is it that didn't work in the past? So it's more like examples that didn't work, and then what could make it better, and examples that would work. So my first slide here is about the knowledge graph in general. Knowledge graph, it's something fantastic and beautiful because we think in terms of knowledge graph. I mean, that's so easy to explain. There are examples in ancient Greek philosophy of philosophers discussing basically ontologies and entities and relationships, just because it's super intuitive. You know, even a child understands the connection. So let's say that our brain loves the concept of knowledge graph. There's almost nothing to explain, right? And in fact, when you start your university courses and they're talking about databases, the first thing that they show you is the so-called entity relationship diagram, when you explain you that information is about entities and they're connected via relationships, you know, like an employee manages a team, you know, an employee manages a team, a customer, an order, whatever. And then what happens is, then the next page on the slide is, okay, that was nice. Now let's talk SQL, right? Let's talk primary and foreign keys and all that. And you're like, oh my God, it's more complicated, you know, and then things become complicated from there, meaning that you don't really realize that vision of knowledge graph. It's intuitive, but the typical SQL infrastructure, that they're not knowledge graphs per se. So people have been wanting to achieve that level, inventing new databases, inventing new formats, just because they felt something new and new was needed. So what I claim is it's almost impossible not to try to invent something new when you're thinking about this, right? So there have been a lot of initiatives over the year, and there have been billions and billions and billions invested by Europe and by US in concepts which should have been completely revolutionary, right? You might have heard the term semantic web. Now it's almost archaeology. This term is not something you will hear anymore, but it's interesting in the context of this thing. So the semantic web is Tim Berners-Lee, after inventing in the web, almost, you know, the first time, if you see one of the first early Tim Berners-Lee diagram, the pages were not just connected with a link, they were connected with a semantic link, meaning the link had a meaning. So that was the author of that, that was the source of that. So the link wasn't just the tag, but it had a semantic. But then he didn't put that concept in the original web, and the web became huge. And then he said, let's do it later. And that's why Tim Berners-Lee and the guys that invented the web, they worked for 15, 20 years on this concept of knowledge web, of semantic web, where every web page was supposed to be meaningfully connected with each other. Now you don't hear about it anymore. Why? There are reasons, and that's actually what's leading to this conversation today, things that didn't work. On the other hand, Google did it pretty successfully. I mean, they have their knowledge graph. It's all interconnected. I know people there. People used to work with us in academia. I mean, now they're working for them, but it's all private and it's all closed and behind their system. So yeah, it worked for somebody, but you don't really see it. Maybe you perceive it. So things that didn't work, for example, and that kind of like starts to lead some principles. So this is RDF, this format that was created by the people in the web, and the billions were invested on trying to use it. Is a super simple language. Now you look at this and you say, well, what's so simple about this? This looks like super complicated. And that's the problem. When you try to make things simple, when you think graph, the graph is so intuitive when you have 2-3 things, right? I know you, you know somebody else, that looks fantastic. But when you look at real data in real enterprises, you know, what this one is saying is that there is a product called 10245, which has a certain weight, right? And the creator of this statement is somebody from the staff. So all that this is saying is that this person said that the weight of this product is this much. So it's just one line of database. It would be a simple line in which it says, this item weighs this much, says this person. But in practice, if you see it as a graph in what I would call a silly way, it is like huge, completely impossible to handle. And I would say that even the efforts of interconnecting many data sets that have been out there, you might have seen this cloud called the LOD cloud, have in a certain sense failed. If you go today and go and see what's actually there of this, almost nothing works. So this didn't work. Then for some people, something worked. Like, you know what this is? This is actually one page on Best Buy back then. They were annotating the prices and the rating of their products. So this is actually how you could semantically look into one Best Buy page. It's talking about a grill. And so this is one of the problem of knowledge graph. If you see that Best Buy page, you understand the grill. But if you see it as a graph of interconnected, it's completely useless for a human, right? So it was good for the machine. So in fact, they put these annotations even today. If you go and see it, you find them, but it's completely useless for a human. So here's maybe a knowledge graph that works in some cases, but not for others. And what about the enterprise, right? So I gave you examples on the web, the semantic, etc., and some of the problems. In the enterprise, I'm not going to go very much into details, but I can tell you that the potential is absolutely enormous, because these technologies sometimes appear to be simple, but then turn out to be very, very complex, requiring people to move all their data into new databases, like throw away your SQL, put it into a triple store or a graph store, and then maybe somebody at the beginning, yeah, let's do that. But then it completely lost any steam once reality, met the project. The reality is that the need for this, it's huge. So I am personally talking every day with industries all the way from policing and intelligence. We are official providers for the police here, and et cetera, et cetera. Clinical trials, you would think it's just a matter of numbers. No, it's a matter of graph. And so there is an enormous and untapped potential, and that's why we're here discussing it. It's time really to create systems that work. So the principles are basically something that I'm I don't like very much calling about the principle, because, if you're talking about principle and indetermination or many very notable principles, those are real ones. These are just ideas. So let's consider them just ideas that might be just better than other ideas that don't work when you're trying to make a knowledge graph. So, and this is also super open for discussion. So by no means this is a cast in stone, but things that have worked better than others are typically very light. So light under many points of view. Light as in, you don't necessarily have to throw away your existing system. Maybe if you can leave the data where it is, you'll be happier. So not necessarily moving away from SQL, but if you can do a knowledge graph on top of that, it will be easier to adopt. Multiscale, it's fundamental. What I mean by this is you've seen those graphs, completely impossible to comprehend, even for very small things. So when you're thinking knowledge graph, think multiscale. How is this going to look when I step back And will I be providing something that allows people to understand what goes on at different scales, right? Smart and intuitive, it kind of means let's not necessarily, so it's basically the point of consuming a knowledge graph. It's fundamental. Like, don't expect that somebody will be necessarily exploring all the knowledge graph and that's how you use it, right? You are supposed to be giving value within the user activity. So intuitively pushing and being smart about how to use those insights into the activities of the users. Then noise and uncertainty, I'm sorry, but if you expect everybody to be adopting the knowledge graph like the semantic web, you remember all those long strings, you had to write that very specifically if it had to work, and that's why it didn't. So anything that's more simple and more adaptive, working with uncertainty and fuzzy data will work much better. And the last one that I wanted to put here was about multi-modality and variety. Knowledge graph is a concept in our mind, right? And it's very likely also in your data, but not necessarily as structured. So you could have a connection, a knowledge graph connection within text. So you have to be ready for that. You have to be ready for text and multimedia. So those are just ideas. And the idea today is to give the floor to our guests and see what they want to add or say. So here, don't forget to add your questions for the QA that we're going to have in the end. So Dan, you be next.
Thanks, Giovanni. Let me just share my slides. So hopefully you can see my screen.
Yes, all good.
Great. Okay, so I want to talk a bit about visualization, obviously, because that's where we sit in Cambridge Intelligence. That's what we do. And I really want to just echo the comments that Giovanni made at the start, talking about, just because you put information into a graph doesn't mean that users are going to be able to understand it or enjoy using it or even get any intuition from it. So I want to talk about that whole idea of intuition and insight. So usually when we talk about graph data visualization, one of the classic motivations that we give people when we say, why should you do this, is, you look at a bunch of tabular data like this coming from a relational database maybe, and you say, can you spot something unusual in that data set? And of course, nobody can. And then I put up a picture of a graph like this one and say, okay, what about now? Can you see something unusual? And everybody says, yeah, it's this strange looking cluster at the top that stands out. And that's one of the most powerful ideas behind a visualization of graphs, is that the human brain is just really good at spotting unusual things in a sea of normal things. And often what you're looking for are those unusual patterns. Very often people are using these kind of graph visualizations to spot fraud or to spot unusual activity. And that's where it comes in very handy. Now, when it comes to visualizing knowledge graphs and enterprise knowledge, sometimes this can work. It can be very useful if you really don't know what you're looking for and you're just a kind of explorer. But I think a lot of the time, and again, to echo the multi-scale comment, a lot of the time you're not really doing this. You're not starting with the haystack, as we would call it. You're starting with a needle. You're starting with a particular piece of information, and you want to understand it in context. So here's another picture. Here's another visualization of a very small piece of an enterprise knowledge graph, maybe. And again, I'm reminded of the picture that Giovanni showed of the little RDF triple store representation where you had a product with a certain weight, I think it was. And you look at that and you have absolutely no idea. I certainly had no idea when I saw that was about the product with a certain weight. So you can see with just a few little visual cues, you can make a huge difference to the understanding of what's going on here. Here we can really easily see we've got a person. That person has a phone number, has an address. Maybe they have an insurance policy. The insurance policy covers a car, and that insurance policy has had a claim filed against it, for example. And just by removing clutter, removing all of that machine readable stuff that nobody really wants to see, and by using a few little cues like a different icon to represent different kinds of information, or maybe using color to draw the eye to say, really, this is all about a person, and the other stuff is context. But what we're really interested in is this person. Those little visual cues can make an absolutely massive difference to the user experience and whether people want to explore data in this way. So really, that's kind of the main point I wanted to make, and the importance of doing a good visualization as opposed to a bad one. Now, the problem, of course, is that this is not easy. A nice visualization like this, here's another example where we're kind of getting both the needle and the haystack here. We're, on the one hand, we're looking at this picture, and from a very high level, I can see that there's some interesting connections down here. These are people talking to people. I think it's emails being sent. I can see there's a lot of emails being sent amongst a group down here. I can see that this person over here on the right sends a lot of things out, but doesn't get much back. So I'm getting a really nice high-level haystack view, but I can also look at the needle. I can look at John here and see who he's connected to and so on. This kind of visualization is not easy. There's so much going on to get to this point, so much modeling between the raw data behind the scenes, which might not look anything like this, and the visualization you see here. We've used size to represent important people. We've done some analytics to figure out who those are. And we've used visual styling to get across the amount of communication by doing thicker arrows, for example. But we've also arranged these on the screen in a sensible way, which someone has had to figure out that it's good to put all of these people in the same portion of the view because they're closely connected. So a huge amount of work has to be done to just get a raw data source, even if that data is already in a graph format, to turn it into something intuitive. So without wanting to do a big plug, but I do need to explain how we fit into things. What Cambridge Intelligence does, we have a product called Keylines, and it basically takes all of that visualization of connected data and does it all for you, so you don't have to worry about those problems. It'll work with any database, and it lets you embed very intuitive, graphically rich visualizations of connected data, graph data in any application. And I just want to finish with a couple of examples. These are little videos, so I hope they come across okay on the webinar. They're not too jerky or hard to see. But a couple of examples here just to show the power of it, of what you can do. So on the left-hand side, one of the big problems, and you had multi-scale mentioned at the beginning, one of the problems is different people want to see a different level of information about what they're looking at. Here on the left, we've got information about machines connected to machines, but one view we have, we're looking at a very high level, we're looking at countries connected to countries, and then we kind of zoom in, and as we zoom in, we open up the graph structure and we look at increasing levels of detail about what's talking to what. This is a really intuitive thing. People love to put things in boxes and compartmentalize things, group them, open up, close things down when they're interested or not interested. That's a really powerful tool, and that can really help bridge the gap between a very complex data set and mere mortal human beings who can't process more than a few pieces of information at any one time. And on the right is an example of filtering, really. When you have a lot of information, you need to somehow cut it down. What we're using on the right-hand side is time. You can see on the bottom, we're scrolling through time, and we're just saying, at this period in time, show me what the knowledge graph looked like. In this case, it's people's ownership of countries, and we can see, if you watch it, you get kind of mesmerized by the connections forming and breaking as people move their allegiances from one company to another over time. Another really good way of keeping things simple is to filter out data and just focus on a little bit at a time. Because really, human beings, we're not really big data creatures. We're small data creatures. We can handle a small bit of information, and it's really important to do a good job of visualizing and interacting with those graphs to help us understand them. So that's all I wanted to say at this point. Any questions, we'll answer them afterwards, and my email address is up there on the screen if you want to contact me.
Great, thanks a lot. Thanks a lot, Dan. Sure, really nice to see this. I do see a lot of research ideas that over the years have made it into this infrastructure. That's great. Thank you very much, Renaud.
Yes. All right, thanks, Gio. I don't have any specific slides, so I will talk a little bit, and then I will share my screen to show you a little bit what we do with Knowledge Graph. As I've said during the introduction, we are a very specific company, and we are designing systems for intelligence agencies. And definitely understanding networks, understanding relationships between people, between entities, is definitely a need for all the intelligence or police forces all over the world. I wrote down for the last 12 years, 15 years or 20 years, but in fact it's almost forever. They want to understand network of influence, who is influencing who is the leader, who is connected to through any ways of communication, ownership, or whatever you could represent on graph. And this is a need that is part of all our project and needs that we collect from our customer on a day-to-day basis. In the past, I too was one of the key player with their product called Analyst Notebook, which was delivered to almost all the police forces or intelligence agencies all over the world. But the main feedback about it was very complex, very difficult to use, needed a lot of training, very heavy, very hard to integrate, very complex. As a system integrator, we have been trying to solve this technical problem, giving our customers solutions about it since almost 10 years now. And well, luckily enough, we met Siren. Siren for us is clearly the solution, because it provides, at the same time, a very lightweight system, easy to use, easy to understand, easy to manipulate, also easy to integrate, and I will also echo what Dan was saying, where visualization is very understandable for human being. Specifically in our field, we are talking with investigators, not engineers, not big data scientists, or even trained people in this field. We are talking to police investigator analysts that just want a representation, a comprehensive representation of the data. Additionally, with Siren, you can always do some additional calculation, filtering, and you can explore your data set from any starting point. And this is exactly what our customers are actually looking for. Just to give you some use cases, some example, a customer will be, for us, looking for example, to find who is linked in any way with known bad guys. Okay, they have a set of bad guys, they represent it at a cluster, and they want to understand who is part of this cluster and who is not. So that's definitely doable with Knowledge Graph. Another use case with Knowledge Graph is to find out, in the middle of a lot of communications, a lot of events, which are the people that are actually only communicating between themselves. So this is a key behavior, very, very suspicious behavior, to have no communication at all to the external world and only communicate within the same group. And this is only possible to visualize with Knowledge Graph. Of course, a key use case, and I will start sharing my screen here. If that works, yes, it will. Okay, you should start seeing my screen now. Here you see the Siren interface with a specific data set that we have built with them for representing actually the call data record, so phone events, who's calling who, who's sending SMS to who. And I'm like sitting in the analyst chair, doing the analyst job, and in red, you see the people that are known as potential bad guys. And thanks to exploring feature from Siren, I easily have found some middlemen that are here that were unknown when I started my investigation, but that are very key, I guess, because they are linking two potential suspects together. So this guy and this guy are actually never communicating together. They are only communicating through this other third-party person, middleman, that I didn't know. And you can see that all my graph, that my graph of bad guys, none of the bad guys that I knew were actually communicating together. They are not in contact. So without this knowledge graph visualization, I could never have known that this was actually only one and single bad guy organization. Okay, so this is a very standard use case for us. Additionally, where Siren is great is that you can take your data and project it over what I call space and time. Specifically over time, this is also a little bit echoing what Dan just said, but you can replay the time here. Okay, it's not updating anyway. You can replay the time and see how the graph has evolved over time. So again, you can use it to filter out and to see how the graph has evolved over time. So it's very key, again, to understand when, for example, when this middleman appeared in the communication ways between this group of bad guys. And same, of course, you could project it, also this data over a map and understand where these people were when they were communicating. So the key here is to be able not only to use knowledge graph as a standard visualization tool, but also as a real analytic tool that will help police officers to investigate about their potential targets. Finally, and even more specifically in the intelligence field, the data is never clear. We need a tool that is able to filter out the noise, the problems. There will always be side effects to the data. We need this kind of tool to actually take care of this data, to clean the data, to polish it, and to manage actually the noise within the data. So finally, what I wanted to conclude with is knowledge graph and understanding how people and entities are linked together is clearly the key for any intelligence investigation. So it's, for me, definitely in my field at least, one of the most valuable things for my customer, and this is where I work together with Siren.
Thanks a lot, Renaud. I definitely, it's really, really interesting, you know, to see how these things are helping in security and policing, and also in the other topics. I guess at this point, if I may, the idea would be to try to discuss and talk about the principles that can be applicable across these use cases. I see that unfortunately we seem to have lost Capgemini at this point. So I don't know if he's going to be joining us again. So unfortunately, I don't see him at the moment. I had several questions, but okay, good, no worries. See if you can join back. But anyway, so yeah, I guess one question that everybody has already is the relationship between knowledge graph and graph databases. I guess it's just like so intuitive to think that if you want to have a knowledge graph, you have to use a graph database. One of the things that, because I know your use case, Renaud, is whatever you've been seeing looks like a graph database, but it's not. It's basically Elasticsearch underneath or SQL. And I know that because, you know, we're making the product. So, okay, we know that. But other than that, in other situations, knowledge databases, graph databases are highly used and appreciated. And in others, they have actually caused projects to fail because they were too complex or whatever. Now, I love graph databases in certain situations or not. And I just wanted to ask you guys, what is your take on the use of graph technologies specifically versus being able to put something on top that's looks like a graph, feels like a graph, interacts, but it's not necessarily based on something different than your existing infrastructure. So I guess I don't know, Renaud, you want to start yourself?
Yeah, why not? Why not? Quick feedback on my experience.
Have you used
here.
graph databases before? I guess that.
Actually, yes, we tried, to be honest, and we failed.
Okay.
So that was a great introduction. We failed for one main reason, is because of the volume of the data we wanted to put in. We are talking about billions, maybe several tens, hundreds of billions of events from multi-sources, multi-types of data, with hundreds of millions of identifiers, and searching through it in a graph database at the time we tried it was clearly failing. So yes, today we build this knowledge graph based on Elasticsearch, as you said, and this is exactly what the, in terms of operational use cases, this is exactly what the customer is wanting. So we don't want to go back to any graph database, yes, because we don't feel the need for it so far, at least.
Okay. And in terms of so then no, we still don't have. So then you have certainly experience with a lot of customers that use all sorts of backends, right? So that the question to you, you have maybe many different products in mind. What's your point of view?
Yeah, it's a good question, and you're right. You know, we see a pretty even split between companies using keylines with a graph backend and keylines without. You saw keylines running inside Siren just now, and as you say, it could be talking to Elastic or anything else on the back end. I think naively you might think that by connecting to a graph backend, you've got an advantage because you've already figured out what's a node, what's an edge, and so you've got one less piece of work to do. But in practice, that may not actually be true. There's a big extra bit of work you really should be thinking about how you convert your raw data model into a visual model. And in some ways, if you don't have a graph behind the scenes, then you've got to think that through and maybe you do a better job of thinking about it than if you just naively assume that all the nodes and edges in your graph database will just translate to circles and lines on your visualization. A really simple example of that might be if you have a data set of, on your back end in a graph, you have people, those are nodes, and maybe those people are connected to countries. So each person is connected to a country. I'm connected to the UK because I'm from the UK. You're connected to Spain because you're from Spain, or France because you're from France. And that makes total sense for modeling the data in a graph database. But when you want to view a bunch of people on the screen, having every person connected to a separate country node doesn't add anything at all. And a much better way to do it might be to show a person with a little flag next to their head or something that shows which country they come from. So there's an extra step you got to take. And yeah, I think it really makes no difference whether you have a graph database or any other database behind the scenes. What matters when you're visualizing it is you think about how to go from the data model to the visual model.
That's great. And I guess the question, however, I want to say, I really would like to have a very balanced point of view. And I know, because I'm friend with, and I know the technology very well, of several graph databases which are doing a fantastic job of what they're doing. There's new breeds of graph databases which are amazing for reasoning, so I really don't want that whoever is following us is thinking, okay, this is not, graph databases are bad. No, I mean, there's some really amazing technology, and for certain use cases, they're completely unbeatable. And so I think one of the things that it's interesting to discuss probably in the future will be when is it that it makes a lot of sense and you're going to be benefiting, and when is it that it's going to drag down your project. And I think also it's very important to understand that. One example for all, if you're looking for extremely fast, shortest path use cases, then you know that a graph database can be pretty unbeatable, because those things, they keep links in memory. They don't have to go through indexes most of the time, so that the speed can be, or you are calculating instantaneous concept of centrality over enormous graph. But sometimes you could say, well, these are edge use cases. while I have hundreds of gigabytes of logs streaming from the telephone system, and I want to connect the dots. So I don't really care about shortest path. If it's 1 or 2 steps away, then it's already good enough for me. And it's not like 15 steps away are going to be, you know, we're all connected 15 steps away, right, with the phone. So that's not going to be useful. So I think this kind of the understanding is very important. I'm saying that under my point of view of talking with so many people, like, for example, in financial institution, the adoption of graph, even databases is very large, and even you wouldn't suspect it. And then when you're talking to the people and you can hear mistakes that you've done many years ago and about choosing these things, and then you're like thinking, oh my God, you know, and then they start. So I think these sort of topics are very important, and it's great that we have a conversation cross industry, because if you talk to a graph database guy, will tell you that it's perfect. If you talk to a relational database guy, will tell you that you don't need them. So I think it's interesting to hear multiple voices. Okay, thanks a lot for your, I'm just looking if we have some questions. Yeah, some of the questions, like, will you be sharing the slides? Yes, definitely some slides will be shared, not the intelligence demo, I think. So, like, this was actually for an yeah, for the payment graph, sorry. And so somebody's asking, will not AI replace knowledge graph? What is the role of manually visualizing the connection versus AI? I like this question very much, because so I have a good answer for this, but you guys, I leave it to you guys, and then I'm looking forward to my contribution. So I don't know, Dan, you have any idea on this topic, on like the importance of browsing manually versus AI or something like that?
Yeah, it's something we think about a lot, of course, because if you take humans out of the picture, then visualization doesn't have much of a place. So we think about it a lot. I don't know. I think usually what tends to happen with AI is that it doesn't really replace humans. It just means that humans are doing a slightly different thing to what they were doing before. I think there's a lot of cases where visualization is just incredibly important, whether you're and you know, what we tend to see, fraud is a really good example, where people are using graphs to represent fraud. Like I showed you that insurance example, and more AI and machine learning is able to detect fraudulent activity and spot one of those patterns. So you're not necessarily relying on the human to spot the unusual thing, but you still need the analyst to look at it and see it in context and understand, okay, the computer tells me there's something unusual here, but I need to look at this and understand why. Maybe I need to present it to management. Maybe I need to use this picture in a court of law as evidence for something and get it on the screen. So I think there are very many uses of visualization, and will continue to be. And what's interesting is just how the two are going to work together in the future.
Great. Renaud?
Yes, so I kind of agree. We need to see the AI approach as a complement to the human approach, for me. Clearly, some algorithm, like machine learning algorithms, such as complex clustering, for example, or detecting unusual behavior of people, will definitely be better done with AI algorithm. But at the end, only the human analyst will be able to make the analysis and to understand actually what the data means. Okay, the AI will be, for me, some kind of add-on, very interesting, very intelligent add-on, smart add-on, quick, to make a part of his job, which he cannot do maybe alone today, but only as a complement to what the human being is able to do by himself.
Thanks, Renaud. Then if I might say, my point of view is, I think knowledge graph represents an enormous opportunity for AI. What do I mean by this is, yes, AI is about automation, right? There is an element of, I'm going to tell you who the bad guy might be, which, you know, might be controversial, but that's what AI does. But AI needs data, right? And data is interconnected. And the knowledge graph, when you create a knowledge graph in terms of data modeling, what you're doing is you are explaining using an ontology or something like that, you're explaining how your tables, which used to be just tables, are interconnected. So now you know that this is, because that is a customer ID shows up in another table, then they are connected. They form a knowledge graph, and then customers buy products, and products have reviews and whatnot, right? So AI doesn't know anything about these connections. So typically, what people do, they put everything in huge file, flat, and then they hope that the network learns. But in reality, if you can give the structure, the ontology of your data to a learning system, then you can hope that AI can learn from, learn what's the path on the knowledge graph, which will give you insights. In some example, you might say, okay, that customer is not that good because if you look at what he bought, et cetera, et cetera. So many hopes away in the knowledge graph, then that you have your value. So if typically when you're feeding a machine learning system, you have to pre-create a model, the inputs, you try to put more inputs. But if you give it a knowledge graph, then using things like reinforcement learning, for example, you can try to learn the path on the graph, a little bit like, playing chess. What's the path that will lead me to the best prediction, right? That will lower effectively the prediction error. So I do think that knowledge graphs are going to be quite amazing in terms of AI, which becomes transparent, which you just add one piece of the graph, and then the system learns how to give value and give a better prediction at the other side of the knowledge graph. And that's how we're seeing it here, at least. So I think it's not going to be replacing it. But so I'd like to another question is, can you guys mention? We have just a few minutes. We'd like to finish on the hour, so just make it quick. Do you have an example of a knowledge graph that didn't work? Somebody who tried. I think I gave an example there with the semantic web, which I think is like a huge scale project which didn't achieve what he wanted because of a lot of the reasons. You guys can you give an example that probably ties into the principles?
Yeah, I can talk a bit about it. Obviously, I wouldn't dream of naming any of our customers and telling you where they failed. But what I would say is where we see success versus failure generally, from our point of view, from the visualization world, is kind of what I talked about before. It's about just making it an intuitive, nice experience. I do often hear when I talk to people about the products that they're making, they say, we have analysts who are afraid of the graph. They see it and they think, oh my goodness, what is this thing? It's terrifying, this spider's web. Give me a nice spreadsheet, because everyone knows spreadsheets. Nobody's afraid of them. So usually for me, where it fails, and obviously I'm biased because I'm on the front end side of things, but where it fails is when you haven't really understood what is the user actually trying to do, what are the questions they're really asking, and how can you give a nice user experience to help them do that. It's not about exposing the whole graph database to everyone. It's about giving them the tools they need to do their job. If their job is to look up a person and find out, do a customer 360 about them, or if their job is to investigate a fraud, then give them the tools to do that. Don't expose the whole database to them.
Yeah, absolutely. I would completely agree. So when you fail to communicate to people the advantage of a knowledge graph because you haven't visualized it or you haven't made it any different from their previous DB application, then people thought, I don't know if you have an example or a comment on this.
It's pretty the same comment. I mean, the failure will come when the user don't know what he's searching for. So he will just use the knowledge graph and ask for everything, and that's don't know where to start, where to end, and what he's searching for. In that case, it's pure 100% failure. From the visualization point of view, also from the backend point of view, from the database point of view, from every point of view. But when the user is guided through a scenario, a use case, or when he knows what he's searching for, then, well, pretty much not so many experience of failures so far.
Okay, that's pretty good. I have several projects that I've heard of a time, like very, very large enterprise product. But again, it's difficult for me to name. But there was people in large companies that were mentioned, named as head of knowledge graph initiative. But they were asking people to change the way they were working, like instead of using that database, copy everything somewhere else, or they weren't tied to the way that people worked normally, to the actual logs. It was like a different system. It wasn't built to be transparent to everyday operations. And that actually ended up becoming kind of like a niche project, which then became a niche failure. And so that became kind of like a bad thing not to mention, or I could mention like excessive reasoning or things like that. But nowadays, you know, and with the, you know, there's this curve. I think we're actually going to be seeing greater and greater adoption now that we know many more things than before. Okay, so I don't know if you're seeing my screen, or just a thank you page, and we are at the hour. So thanks everybody. This one will be recorded for people that want to follow. Next events are going to be announced, so please sign up. There's a link here. Next thing I really want to invite everyone to, it's also our launch, the product, the Siren product, Siren 10, which has to do with knowledge graph, of course. So it's one of the way of seeing it. So please follow us. This will be in, I think, 3 weeks. But anyway, we'll send out the announcement. Thank you very much, everybody, and have a great day. Bye-bye.
Thank you. Bye.
Bye. Thank you.